Hello, 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 and welcome back to another episode of Today's Weather Tonight. Here, as always, I am your meteorologist for the evening, Cloud Hudson. And tonight we have breaking news, breaking storms. Storms are breaking everything in Oklahoma. Let's go ahead and take a look at our radar Omega so that we can just jump into analyzing what the hell is going on out there in the plains. Get this in the number one spot. Okay, so as you can see, we have 47 active alerts from the National Weather Service. That is a lot. A lot of it, I mean, some of them are special marine warnings. Some of them are like marine. We're looking at Mason, Michigan, and Racine, Wisconsin, Kenosha, and Milwaukee. But that pales in comparison to the fact that we have 11 warnings. 11 tornado warnings indicated as a City, and the one in Wilson, Kansas. Now, let's go ahead and look at some of this radar out of Oklahoma City. Populated area. This is an area, I mean, accustomed to storms, but you really don't want to see this this kind of rotation in a densely populated area. Now, so that we can see the rotation better, looks like this right here is the cell. This one, and this one, all three have tornado warnings on them. Let's take a look at our perhaps. Yeah, okay. Okay, so we are seeing right here, this is the outflow boundary. This is this right here up at near Holdenville is one tornado. This just north of Sulphur and southwest of Roth is another tornado. And this right here near Stratford is yet another center of circulation. Let's see, because that will hail cores, all three of those things. And you can see this one. This one's almost in the one. This one near are doing. Okay, looks like we're not exactly going in the direction of the debris ball on this one appears to not be going in the direction of the storm. This right here is definitely a debris ball, and this right here is definitely something gnarly, I would say. Let's take a look. Let's click through let's look at our reflectivity again now that we know where it is right here. Let's see the velocity will show us. Yeah, okay, so just right over Spalding is the center of circulation. So this right here, this is the tornado. Probably will appear rain-wrapped to people coming on 270. God, look at that nice defined hook. This is a beautiful hook echo. Beautiful and terrifying. Awesome would be the right word. Awesome kind of has connotations of being a word. Awesome means it leaves you full of awe, and this would certainly leave you full of awe. you almost see the old man walking shape in the cloud itself. And that's a shape where there will be multiple vortices swirling around before a real funnel makes it down in one defined funnel. There can be multiple ropey strings of rotation that combine to become a tornado. This, however, this hook echo is so well defined. Let's click back a few. Let's click back a few frames. Warning started. We start to see the development of a little bit of a hook. There's a hook here as well, but that's not going to be the one that forms. As we see, they merge with each other right here, creating this little center of circulation. And as we head towards Spalding, that recycles back into the storm and is, damn, that is a juicy hook. Because one side doesn't mean that's not part of the tornado. Oh man, this is even more spirally. The new frame just came in, and this is even more of a defined spiral. Do you see that 6? Oh my gosh, this like almost has an eye. This looks like a hurricane with an eye wall right here. That is ridiculously big and powerful, and that is coming straight for just through Holdenville, Jaeger, Wewoka, and I bet this is going to get extended into Cromwell, Okama, Castle. We are still also not out of the woods for anyone behind here. The panhandle of Texas. As you see, this is where we've got a low, dry air mass, a hot one too. And we have severe thunderstorm warnings in this area, watches and warnings. We've got I can't select the can I select the sometimes these polygons are hard to tail radar indicated. Where this is all you video game nerds, like you know the term or concept of a spawn point. It's the area where on the map where your video game character starts off a level, or when you die and is regenerated, goes there. We're up to 54 alerts right now. This right near Ardmore has just been indicated as a tornado warning. You can see another little hook on there. Let's take a look at what that looks like in motion. Oh yeah, you see the dangly bit, as Ryan Hall says it. The dangly bit, that is a nice hook. It's fallen apart a little bit, but it looks like it is set up. Okay, it's set up to be a here from of air into here, and air from the spawn point from so we're getting kind of a convergence of air from Wichita Falls and from Paris, Texas, that will go into this Ardmore point. And honestly, a severe thunderstorm, tornado possible, wind 60 miles an hour. We are in a tornado watch for all of these counties. We're in a tornado watch from Abilene, Texas, all the way up to Illinois to yeah, Illinois all the way to Abilene, Texas, a tornado watch. Okay, we just got a new special weather statement here. Radar indicated thunderstorm, gusty winds up to 50 miles per hour. I'm not going to dwell on any one warning too much. Okay, this Holdenville Spalding one has also gotten a new polygon added to it. You can see in this, do you see it wrap in on itself? Think of clouds as a fluid. Do you see the, it's kind of trying to to vertical with our velocity gradients. So it's spinning up into this like, honestly, looks like somebody doing the ball gazer hand motion. This ball gazer, when people like put like it's like, oh, you're gay if you look at my hand when I'm touching my thumb to my pointer finger, that is the shape of a classic supercell tornado. So when you see the ball gazer format, that form, you know that we are looking at some big tornadoes. Ball gazer shape equals big. You're just getting some, oh, just extremely cell popping up on the border of Oklahoma and Texas. That is, and also look at all that lightning damage. Okay, let's take a look at all of our other tornado warned storms. There's so many tornado warnings up right now. Hail up to 1.75 inches there. We're going from Chanute to Ellsmore to Bronson. Iola, Kansas, Humboldt. Let's see. Let's look at this on velocity. You can see all the different polygons on there. There are so many warnings. There are green for flood warnings, yellow for tornado watch, orange for severe thunderstorm warnings. Let's see. What's my best radar station from here? Is that going to show it? Okay, it looks like this one just expired, actually. So that warning just expired. Let's hit play. All right. Oh, here's a new flood warning has been issued. Flash flood warning for Nevada, Missouri. Let's see what our local reflectivity looks like. Oh, yeah. Look at that line. This line is, again, moving in the same direction as its shape. So I thought of a better way to do this. Where's a pencil? Come on, anybody got a pencil for me? Oh, here, colored pencils. There we go. That'll show. That'll show well. That's got something. Okay. Okay. Again, I'm about to refresh my radar Omega because it froze. But in the meantime, let me show you. remember I tried to explain it yesterday this way. Well, I figured out, I think a better way to illustrate this would be to do the shape of the storm is going to be the plane that I am rotating, or that I am moving this pencil back and forth in. Okay? So when the storm is moving that way, and the axis of the storm is this way, we get a shading like this. You know, something that is definitely heavy, but dumping it over a larger area. Now, when we get axis of the storm parallel to the motion of the storm, that's when we get something like this, and I am shading the same heaviness, but it goes way darker because I am moving in the same direction as the storm. Storm comes from here and just stays in that one little stretch. And that's why there are these stretches of warnings here. Now I've got my radar Omega back up. But yeah, you see how that difference works? Do you see how this would be a flood and that would be pretty mild? This flood, this just normal rain. Okay, so we are looking at flooding and tornadoes at the same time here. Okay, let's see. Jefferson City now has a tornado warning, radar indicated. Let's see what it looks like there. That's one of those Boeing boundary ones. I bet on velocity, it's going to look like a little serrated edge and have one of them. Yeah, one of them. Couplet right here. That's the couplet right here, right over Syracuse right now. Let's see what that looks like on Columbia radar. Oh no, we can't quite see it yet. Can we see it on the that's the Kansas City radar. Here is, okay, that's a better one. Okay, and we have a new tornado warning for this same storm. There's our velocity couplet, now stationed right over Syracuse. You can see this is the serrated edge I was talking about. Here's the wave, and here's where the wave is crashing. Remember, the spiral motion is a wave crashing motion. It just depends on the plane of perception. Let's look back at, let's take a look at reflectivity on this one. It's this notch right here that we're looking at. This bowing out section. It's got a little bit of inflow. Not looking good for there in central Missouri, headed right towards Columbia, Missouri. St. Louis is also under tornado watches. We have really high DBZ up here near Quincy. Let's see. Nevada is also looking very rainy. Let's take a look at let's go back to our composite, not single site. Okay, so this should tell you everything you need to know. Well, not everything, honestly. This is where we've got enough moisture. We don't have enough moisture to convect, but there's a lot of clouds trying to do something. Okay, we have a tornado warning here north of Abilene, tornado warning in Ardmore, a stretch of them, actually. This has been warned all the way up to Ada, Oklahoma. And that it's about to overlap with the warnings that were here in Spalding, Holdenville. So let's take a look. That one really cycled up and might be going back up into the cloud, but I am not sure. We've got this Ardmore one working on spinning itself up more. Let's go back to, well, before I stop, let's review all the tornado warnings that we have on the ground right now. We're looking at a tornado warning here between Chandler, Stroud, Cushing, and Yale, Oklahoma. That is southeast of Stillwater, where earlier in the day they saw a tornado on the ground. I haven't even reviewed what we've seen since 3 p.m. today. There have been constant tornadoes all day in the Midwest. This is all headed towards Tulsa now. So Oklahoma City is a little bit out of the firing zone for the moment, but everything is headed towards Tulsa. So let's, everybody is aware of that. It is pretty, I know that tornadoes happen at night all the time, but mostly in the South, the deep South. I don't know if folks in Oklahoma are used to having such late night tornadoes, since they usually get the peak heating of the day, early evening, late afternoon type of tornadoes. You can see with this line, they are all trying to spin in that DNA shape. Okay, we got another tornado warning for the Ardmore cell. Let's see. Looks like it is over Gene Autry right now, headed towards Doherty and Sulphur, which is where a different one spawned earlier. These are all moving in the same direction. This tornado behind, there's a tornado coming right behind this tornado. These are radar indicated again. Okay, and then just north of Abilene, we do have another tornado warning. Zooming out, let's see where else we've got a tornado warning. Here in Columbia, Missouri, this has remained tornado warned. And yeah, let's see. How many tornado warnings do we have active right now? This is gnarly, y'all. 14 active tornado warnings, 15 severe thunderstorm warnings, 13 flash flood warnings, 15 tornado watches that include multiple counties each. We are at 49 total alerts right now. Let's see. We have an observed tornado in Lincoln, Oklahoma. We've still got a observed tornado in Hughes, Oklahoma, and Seminole, Oklahoma. Let's see. I think that is the one as we get up to. I wanted to say that one was closer to Tulsa, but yeah. Also, Wichita Falls getting pounded with rain right now. Absolutely hammered. Let me turn off. Oh, we got a special weather statement out here. Radar indicated gusts up to 40 miles per hour. Here in Nebraska. Nebraska also had quite a bit of severe weather today. Wow. Just wow, honestly. This is stretching all the way up into Milwaukee now. McHenry. We're right on the border between Illinois and Wisconsin. This McHenry, Illinois cell looks nasty. Headed right for Kenosha and Milwaukee. Not quite as severe as our active tornadoes spotted on the ground, but still really severe, capable of producing hail. Probably not a good situation to be in if you are there. Now, the hard part is if you're warned for a flood and a tornado at one time, what do you do? because for a tornado, you're supposed to get to the lowest level of the house. For a flood, you're supposed to get to the highest and driest. Oh God, and look at these cells right behind that Ardmore. They keep spinning up. They keep spinning up off of this inflow area from Dallas. Like, really, it's coming from Fort Worth, this big gust of angular wind to the big frontal boundary. And that is creating a lot of spin up for our tornadoes. So a huge weather day here in the central US. Let's see, where are our marine warnings? Oh, our marine warnings are up here in Milwaukee. Special marine warnings. Probably getting a gale force winds. Let's see. Produce capsizing waves. Let's see. I mean, as this feeds over Lake Michigan, it's not it's not weakening. It's, if anything, picking up some moisture. You would think that after going across the whole country, these storms would quit, but no, they are not running out of juice. There's a center of circulation up here in Canada that's like pulling this along. Storm into here, even though our storm we're looking at, the center of circulation is just over Dodge City. There's a center of circulation up here in Canada that is, you can see the connection right here. You can see how things that are flowing out of this circulation are flowing into this circulation. There's also rain in the north. Honestly, I wouldn't be surprised if we get tornado watches into Indiana by the time the night is over. There is a crap ton of rain falling here. Here in Big Lake, Texas. Yeah, that Abilene storm is still tornado warned. Let's see. It's a special weather statement here. Radar indicated gusts up to 50 miles per hour. Oh, and we have a new tornado warning issued for the Ardmore cell. Hail up to 1.25 inches. Let's see. Shit. A particularly dangerous situation. Immediately life-threatening danger. Mobile homes will be destroyed. Considerable damage to homes, businesses, and vehicles is likely, and complete destruction is possible. Mill Creek and Lake of the Arbuckles. Take cover now if you are anywhere near Ardmore, Oklahoma. Let's go back to our single site radar so that we can see some velocity on this again. Want to see, honestly, was this one going to reach, or should I go for, it's not a radar hole, but it's not an awesome site to be in. Okay, there we go. The Fort Worth radar is getting it well. Let's see. So they're going through. Oh man, and then this looks to me like somebody blowing across a fluid, like cooling off soup. That's this, and that produces a lot of vorticity as well. So looks like we might keep spawning, honestly, because we have a warning south of Ardmore after this cell that we're talking about has already passed through. There's another cell that looks like it is about to produce a hook echo. So all of these are still really nasty. We're not getting very good coverage on the velocity here. This looks to be the little couplet that we are warning for in Marietta. This Ardmore tornado is probably up here, this area right now. Let's see if I've got a better view from Oklahoma City. Yeah, this is a better view of that Ardmore cell. Look at that. The yin-yang sign, that is what a tornado looks like on high-res velocity, on the velocity signatures. Okay. That is gnarly. It looks like it's not quite as tight, but it is, ooh, not good. And you see coming right behind it here in Thackerville and Marietta, yet another velocity couplet. We're looking at, let's see. I want to say even here in the Chickasha Nation area, either there's a lot. Okay. And that probably recycling, but it looked very nasty. That is the one started off in sulfur here. But right behind it looks like another area of rotation. And another here in Ada, Oklahoma, right near the Ada airport, I guess. That is a velocity signature right there. That's a velocity couplet that we're watching. Honestly, there's two little areas that might try to merge. As we're looking at the Oklahoma City velocity radar, and again, this one that started in Spalding, went through Holdenville and past Yeager, is wildly developed, like very, very, very good geometry. Looks like it is starting to get reconstituted into the larger frontal boundary. But let's take a look at that on radar again. On reflectivity, I mean. Yeah, you see how that looks like a come hither or a scooping up motion? That scooping up, that is the hook echo. This is the larger, this oval right here, you want it to look like a cornucopia, like the Thanksgiving Horn of Plenty thing. That's what will produce a really strong hook echo. That has got to be a very dangerous storm. Let's see what it looks like on correlation coefficient. Oh, yeah. That is big old debris ball. It's not big of a debris ball as you'd expect. It probably is going over some rural areas, so probably not picking up too much. But wow. Let's look at that on specific differential. Whoo, buddy. That peaked out. That peaked out near Wewoka. I don't know how to say that. Okay, Seminole. This is the one that was confirmed on the ground. Yeah, this is where we're near Seminole. That is the one that has been confirmed. Let's see. What are the other? Yeah, and this string of tornadoes. This isn't even a string of cells. This is a string of storms. This is a string of tornadoes specifically. This serrated knife edge looking thing, that is producing tornadoes like crazy right now. Honestly, also, let's look at near Moore, Oklahoma. Not looking great. Looks like we have some very different velocities in play right there. Not a tornado shaped velocity couplet, but still the lamination. It's the stripiness that you don't want to see. You don't want to see a complex edge. If you don't want to see you don't want to see a complex edge on these polygons. not polygons, because that will make people think about the warning areas. You don't want to see a complex edge on your velocity signatures. The wave spreading through, not great, not awesome. The Storm Prediction Center is here in Norman, Oklahoma. That's the head of the National Weather Service is down there in Norman. I have been there before. I've also been to Moore. Remember, Moore has had 2 very deadly EF5 tornadoes go through it in the same exact path. So that's why I'm still keeping an eye on this area, because even though it's not actively tornado warned, I don't like the look of that little velocity signature there. It looks like it might want to spin. Let's see what it looks like on 3D though. Going over. It's probably just really a tornado is really strong winds. Let's see. Cushing, we are looking happening. We're seeing the double helix Marietta and Ada, Oklahoma. There's just one long string of tornado warnings because these are nasty. I'm going to keep checking in on this, and we are going to get through our update today, but I want to see these on velocity. There's 1, there's 2, and there's 3. 3 different tornadoes all going in the same track. I don't know what's going on the ground out here, but it looks nasty. It looks gnarly. It looks like it is going to continue to try to produce some really damaging situations here. So I'm going to go back to looking at our reflectivity, and I'm going to leave this page up while we continue to talk about our other weather. I'm going to zoom in on this cluster of tornado warnings so that we can have that going in the background. Okay. Now we talked about our earthquakes. Let's talk about our volcanoes. Let me add that radar to the picture here. Don't laugh at my targeted ads on my homepage. You're not allowed to laugh. You are allowed to laugh. They think they're going to get me with what happens if Yellowstone erupts. I know what happens. Okay, let's go for tornadoes. The tornadoes that happen inside the molten ground, or otherwise known as volcanoes. Here's a map of our actively erupting and in unrest volcanoes. Ibu volcano, Halmahera, Indonesia, experienced an above average explosion, sending ash up to 16,000 feet into the air tonight. That is duration of 206 seconds. The continuing lava dome is actively growing as viscous magma continues to rise into it and form a faint glow on top of the dome. Thus, it extrudes lava dome blocks into slowly advancing lava flow, so-called coulee, on the northern flank. In order to mitigate risk, people are okay, the exclusion zone is 2 kilometers from 3.5 kilometers from the crater. So yeah, let's take a look at Volcanoes Today news. Yep, and again, there's that Mount Ibu eruption. Shivaluk-Kamchatka has some volcanic explosion going on. Oh, that's Samiru. We don't have a picture of Kamchatka. Estimated to 15,000 feet. Mount Ibu, we just went over. Tofua's Lofia Cone. That is, Tonga Islands. So we've got strong radiation, a strong thermal signature coming from Tonga, which we've seen a lot. Y'all know we see a lot of earthquakes in that area. It's a lot of strong earthquakes, not little tremory types either. Dukono continues to explode. Tofua in the Tonga Islands. A new eruption commenced at the volcano's caldera. This might represent a new batch of magma shifting inside the conduit at high levels. Nevado de Ruiz keeps exploding. Sangay keeps exploding. Volcanic ash cloud observed to 20,000 feet. flight level 200. Reventador, Ecuador, has some discrete volcanic ash emissions, and Sabancaya in Peru is giving us intermittent ash emissions, but it's going really high to like flight level 220, which is 22,000 feet in the air. Yeah. Let's see. What else? Got a Rearcast update. The ongoing increase of magma volume at the Svartsengi region is consistent with model predictions. The total amount of magma added to the chamber since the eruption began on March 16th is now approaching 10 million cubic meters. Historically, magma influxes from the Svartsengi have occurred when the chamber has accumulated between 8 and 13 million cubic meters of magma since the last eruption. Additionally, there is a possibility of magma surge leading to new fissures opening outside the usual area between Storskogafell and Hagafell. However, this scenario is deemed less probable than others and would likely be accompanied by significant seismic activity and deformation, providing more advanced warning compared to previous eruptions. Remember that our last eruption came on with like 15 minutes warning. This is what they're talking about here. We are looking at, I believe, let's see, where are the dates that we're looking at? This most red one here is where we currently are sitting. And that is the level that we reached the last time there was an eruption back in, before this current one, back at February. We're around the inflationary mark that we were in February. Let's go to the actual website because I forget if the square or the star is dike intrusion or eruption. Okay, here's our update. April 26th. Here is a picture of the active eruption. This is the Sudnuker. This is Hagafell, that mountain that we've been getting really good, mountain hill that we've been getting really good data from. Okay, yeah. The squares are where we have had new dike formations, and the stars are where we've had new eruptions. So we are well past the inflationary stage that triggered, or that was the inflation episode between March 3rd and March 15th. And they've started counting this last eruption as starting 317. We are well past that. I believe that we are getting into the territory of inflation where we are due for either a new dike to emerge or a new eruption site to emerge. New eruptive fissures may open up. It may propagate from the Svartsengi Reservoir to the Sudnuks crater row. This could happen gradually until a balance is reached between inflow and outflow. Here's our volcanic gas pollution, sulfur dioxide in the atmosphere, clearly visible on satellite imagery. Let's see. Part of the lava field near the barriers of East Grindavik continue to thicken slowly. Ground uplift in the Svartsengi area continues at a constant rate. As long as the magma continues accumulating in the Svartsengi reservoir, the likelihood for a significant escalation in the eruptive activity in the Sudnuk crater row increases. Continued hazard due to gas emissions in the area. So, what does this mean? What I'm summarizing. They already have an active erupting volcano cone, and the ground is still inflating much faster, inflating with magma much faster than it can erupt out of the one and only crater left in our March started eruption. That eruption has been going on for over a month, and the magma below the surface just can't wait. It's too antsy. It is swelling up. It's like when you're pooping and you have gas at the same time, you're like, how do I have gas pain if I'm actively pooping? That's what's happening to the Reykjanes Peninsula right now. It is actively pooping out lava and still inflating with gas. It's quite the sight. Let's take a look at our wind. Wind direction is fine. We are looking at let's look at our earthquakes though. We are looking at some continued constant quakes. I like to think that when the intensities are going up and down, or when the frequencies are going up and down, that it has something to do with the tides. But that's completely unproven theory that I have. Let's take a closer look at the Reykjanes Peninsula. Again, looking at, I mean, only peaking above 2 rarely, but still looking like we have continued activity. Let's go back to regular ongoing volcanic ash emissions at Samiru. Okay, that Puyehe Cordon Caja in Argentina and Chile looks like it's not erupting anymore. Okay, yeah, we've got a lot of activity going on all spheres of weather. Let's take a look now at our Schumann resonances. Let's see if, because guys, we've been getting hit by a lot of radiation from, not radiation, we've gotten hit by a lot of solar storms recently. So this uptick in earthquakes does not surprise me. Again, we talked the other day about how little blips in the higher mode might indicate more earthquake activity. And look here, look in this little area. We've got, again, power bursts in the 4th mode of the Schumann resonances, not in our lower modes. Usually intensity Shit. When did I go offline? None of y'all were going to tell me that I went offline and it kicked off my... Who was going to tell me? Who was going to tell me that my screen went offline? Okay. I am kind of frustrated with Streamlabs for not letting me constantly keep this up here. Even though... Yeah, okay, so we're talking about a fuck ton of water being dropped over the entire Midwest. Look at this bowing out right here. Do you see this shape to it? Yeah. That's a strong signature of continued convection in this storm. Let's see. God, and we're looking at 24-hour precipitation is already into the 3s and 4s inches. And then when we add in how much we've gotten over 3 days, we're getting up into the 5-6 inches area. And we are forecast to have like 3 or 4 more inches in some areas of Oklahoma overnight. So that is so much water. That's just like California was in this winter. Okay, let's see. Oh my God, I've been streaming for 2 hours. Holy shit. Let's get to our cards. Let's get to our cosmic weather and close this out because God, that's a lot. That's a lot of weather. That's a lot of weather. Don't forget to vote in the comments for what you think my branding should be. Do you guys like my prototype my prototype logos? Today's weather tonight. It's gonna form a cloud of some sort, but I haven't decided on the arrangement yet. This one looks pretty good. This is a front runner, although it looks a little bit like a mushroom cloud, but maybe some of these little takes on it near there would be better. Anyway, let's get a read on the cosmic weather. And if y'all have never been to this stream before, you don't know what I do. This is a weather update that includes all forms of vibes, because the weather is vibes. It's just vibes that we can measure good. I say measure good on purpose because I'm trying to convey that I'm dumbing down things when I say vibes. I mean actual waves, waveforms, and different things. But and so we go through volcanoes, earthquakes, terrestrial atmospheric weather, Schumann resonances, solar weather, planetary weather, and then beyond that, we do a card pull for what the cosmic weather is, for the things that are in the fields of space that we don't have a good technological grasp on yet. So we can only kind of go by vibes. We can read what's happening out there through the chaos and the intention of magic. I got oracle cards. We've got welcome back. Some of y'all are just returning. We've got the liminal space deck, and this is a very liminal space. This is a very liminal stream right here tonight. So I'm gonna go ahead and start with this one because this is just such a very special episode, such a long episode today. Let's see, what's our cosmic weather today? Spirit split. Spirit split. This is another one that I have never drawn before. Let's see what Spirit split says. Guys, this is part of the weather, I promise. I promise that me using oracle cards is part of the weather. Okay. Spirit split says, from divine retribution to demonic possession to spiritual channels to the birth of a healer, madness and godliness have been intertwined in their attempt to be understood since the beginning of written history. Cells must divide to grow within reason. At this particular moment in time, are you a spirit or are you split? Let's see. I'm actually going to put my radar in the corner again, just because it is continuing to... God, this is continuing to be just the craziest little radar ever. Not ever. There have been crazier storms, but it is a very crazy storm right now. Also, for it being day 3 of this severe weather outbreak, this is remarkable. Okay. So that's what we've got from the liminal space, sounding like I'm not crazy, I'm a shaman kind of energy. Let's get a tarot card to go with this. Well, do I want to? Well, actually don't think I'm going to pull a tarot card today or a manifestation oracle. I just want to do spirit split. I think that is a good summary of our cosmic weather coming in. Chaos, chaos, chaos. Nothing happens without chaos, but also nothing exists without order, and either of them couldn't exist without the other. So I just want to go back to this radar again. I'm sorry. I'm definitely all right. 2-hour stream. 2-hour stream. Okay, we are going to stream for 2 hours. Let's go for it. We're going for it, baby. Okay, let's take back a look back here at, we're going to start at the bottom. We're going to start at the spawn point. And remember, the spawn point has moved southwards, south and east from Big Lake. So out here in the Sonoran Desert, imagine you're a little piece of air. Imagine you're a little air molecule going through this storm. You would start out back here. You'd track through this severe thunderstorm watch and this special weather statement in San Angelo. We've got radar indicated gusts up to 50 miles per hour there. Then you would spiral rotate like a spiral notebook, That's an inside joke for my mom if she gets it. My mom does watch this, so be nice in the comments or be mean. She doesn't believe that people are mean to me, so prove her wrong. The spiral notebook shape of the roll cloud, you can see kind of here between San Angelo, Abilene, and Throckmorton. Got such fun names out here. You can see the shapes kind of rotating like a double helix. There's like a rolling, twisting, looking like the hair getting turned, like where there's individual strands all turning. And then this turning is also having its own individual movement. Do you know what I mean? Okay, so that's happening. We go up through Wichita Falls into some gorgeous country. I went hiking out here when I went storm chasing once. It's a beautiful area, but also very conducive to spawning more convection. You see the roll kind of break up here near Olney and Henrietta. As we go to Ardmore, we had a different spawn point because we have this flow coming from near Fort Worth. I think that will be, we didn't even look at satellite yet. Oh my gosh. I think that is where we're getting some inflow from the Gulf of Mexico, probably coming up through Houston, through this area. And the spawn point from the Sonoran Desert and the spawn point from the Gulf of Mexico meet up here near Gainesville and Ardmore, right on the Texas-Oklahoma border. And we've got a continuing, we've had, since the beginning of the stream, there's been tornado warnings in this area. They are starting to migrate north and east, but we continue to see rotation both in the horizontal plane and in the vertical plane. Marietta has been a spawn point of little bean-shaped clouds, little shrimpy shaped clouds, and those can also spin up their own tornadoes. We're going to get through the journey of being an air parcel, and then we're going to come back and look at that south of Ardmore cell that is just now creeping up this little crescent moon shaped area near Marietta, Oklahoma. Okay, so we've got a kink in the line here near Colgate, Tupelo. This is probably looking like a velocity couplet. On velocity, we'll go back and look at velocity on single site radar in a second. We've also got behind this little stretches of convection popping up between Cheyenne and Woodward in Oklahoma. Then as we get up towards Okmulgee, we've got another, this is a really beautifully spiraling spot. Do you see there's little like flanks of, I'm imagining these as spirals where it's a thicker cloud, where there's a larger area of red and orange, that being like near you, and the thinner area of orange being away from you. What it would look like if you were looking at a spiral. There would be part of the spiral visible close to you and part of the spiral visible far from you. And when you see them rotate and move, this is showing rotation like a spiral would do. So that happens in the horizontal plane parallel to the surface of the Earth. But when that starts to sag down, it can do the rotation in the vertical plane, and that spawns the tornadoes. There's also this thing where little waves in the edge of the line, the frontal boundary, or the front of this boundary, these little kinks in the line will create their own little hooks. So right here near Hannah, we are seeing a little outcropping that might spiral into something. So let's continue pretending that we are a piece of air that started southwest of San Angelo. We have made it all the way up to Tulsa, where there is now both more isolated cells and chances of tornadoes, but also these big swaths of strong rain. Just because they're not strong reflectivity signatures doesn't mean it's not raining. There's a continuation of rain all over here, from Sedan, Kansas, up to Fredonia. Flash flood warning in this area. Let's see. Expected rainfall rate is 1 to 1.5 inches in 1 hour. Additional rainfall amounts of 2 to 3 inches are possible in the warned area. That is a lot. That is like monthly rainfall totals for the areas, all in one night. And that is continuing up to Fort Scott and Nevada, on the Kansas-Missouri border. Then we go up to Jefferson City, Missouri. That's where our next edge of the storm is. But now we are getting to the point where the shape of the storm is less parallel to the direction of the storm, or we're trying to be. This area here, we've seen nonstop rain, not because and we got another new severe thunderstorm warning for hail up to 1.25 inches, just north of Abilene. You see how this is, it's flattening out. That is less likely to, well, first of all, it's going to do the thing where we've talked about this, how a storm that is moving in the direction of its shape will dump way more water over one point. A storm that's moving perpendicular to the axis of its shape is going to dump less water on an area. We're getting a little bit more into perpendicular to the storm shape here, but not very. We're still moving lengthwise instead of side to side. That real meridional motion is not good for avoiding heavy flooding. As we get into Illinois, we are looking again at tornado watches. So all of this area is still very possible to spawn tornadoes at honestly any moment. Any of these little notches in the line could start to organize itself. And in fact, here near Hannibal, Louisiana, Vandalia, and Pittsfield is this in Illinois still? Yeah, it's like right on the border, on the Missouri-Illinois border. We are looking at that looks to me like it's something that wants to develop itself, make something of itself, you know? Then up here towards Rushville, as we get closer to Chicago, like the storms are moving towards Chicago. Chicago's gotten it kind of easy tonight. Milwaukee to Kenosha had a lot of this earlier rain, but this severe storm is headed right towards Chicago now. Probably these are playing in Peoria, all right. This is, I mean, we have a flash flood warning near Peoria and right near Eureka. There's also this chain is diverging at this point on either side of Chicago to go up the Milwaukee way or towards Toledo. And if you go up the Milwaukee way, you are headed into Canada. And if you go the Toledo way, you are headed into this stretch of air that goes through Toledo, Cleveland, Akron, and into Philadelphia. So if you are part of the air mass that goes either way, there's a bit of divergence. And again, you get up here what I call the crashing wave shape. This spiral. Wait, let me get my zoom better. Yeah. This spiral shape right here, that shows our center of circulation. That is also visible here with our main storm, although this is kind of got two components here, right? Here's our center of circulation. Here's the back of the wave where it spirals in. This is the upwelling. This is where the crashing of the wave sucks things into. This triple point here, this triple point between Wichita and Springfield and Joplin, this is the area where we're having the most convergent. This is looking like the inflection point of the wave to me. And now that's not necessarily where the tornadoes always form, but it is the heaviest density of warnings we've got currently. It's also where we've got the most flood warnings. And it looks like, oh man, and this Woodward cell is just getting more and more infected, like an open wound. Also, I want to note that this area is in a very high fire risk. So any very heavy lightning activity that doesn't come with a big soaking rain is just begging for a wildfire. So we also have isolated cells in Fort Worth, but we've seen that all day, honestly. Okay, let's go back to our yeah, this is going to be a marathon stream. I don't even care how long this takes, but I have so much to talk about with this one. I didn't even get into the tornado reports. 128 tornado reports over the past 48 hours. And yesterday, this time, we had 99 tornado reports. These are combined from yesterday and today. But okay, so from Wichita Falls to the Chickasha Nation, we had multiple noticeable TDS as tornado moved through town, widespread damage through sulfur. I think that was from yesterday. Between Moore, Oklahoma and Norman, Oklahoma, we had notable damage at Homeland. Stronger radar signature matches at this time. Additional damage around Norman. And remember, Norman, Oklahoma is where the National Weather Service Severe Weather Prediction Center, Storm Prediction Center is situated. So that's not a great place to have a tornado, even though it does happen from time to time. As we zoom out, we're looking at southeastern Kansas has had a lot of tornado reports. We've gotten a lot of tornado reports along the Iowa-Nebraska border. That is where we were forecast to have a lot of tornadoes. Had some up into Des Moines as well. Our most recent confirmed one is, let's see, Holdenville. That one, Holdenville, we saw large TDS impacting Holdenville with widespread damage reported. Okay, yeah, there's been a lot of, okay, here's the Ardmore report. Twitter photo as a tornado moved through Ardmore. I don't know why the photos aren't loading on my current thing, but let's take a look at, I haven't gone to the GOES satellite today to show you the derived winds. I like to analyze derived winds because I'm a dork, because derived winds helps you visualize the different layers of the atmosphere. For instance, right here, near Cuba and the Yucatan Peninsula, we've got really strong shear, really strong wind shear, both directional shear and velocity shear. And both of those things will contribute to vorticity. Vorticity is the variable name for spinniness. Spinniness is a very technical term. So it's not a very technical term. So we say vorticity instead of spinniness. This lower level wind here is represented by the yellow barbs, and you can see it recycling from the air that's coming off of the Northeast. It's cycling back in across the Atlantic, across the Gulf, and back into this storm. It's creating its own big cell of rotation. That's technically anticyclonic rotation, but it is still a self-feeding loop where this goes over the land, dumps its rain, then dries out, goes over the ocean, picks the moisture back up, and can come right back into that same conveyor belt. You see, the center of circulation was what was over the Four Corners region yesterday, and the low that's up in Canada right now is what spawned yesterday's big weather. And we've still got rotation in the Four Corners region, so probably not looking at letting up anytime soon. So here's that upper level jet stream, that tropical jet stream that is really strongly interacting with the lower level winds. It's creating this motion. It's creating a vertical convective cell where there's overturning. There's also a lot of lower level air feeding in across the Gulf. As I was saying, yes, this going from the Gulf up through Dallas-Fort Worth area into where our frontal boundary is, that's what's creating, that's what's fueling, that's the inflow on this big storm. This is honestly not looking good right here. The waviness in the right edge of this storm is not happy looking. We see aloft and at mid levels, we've got a strong circulation. Then here in the clouds, the strongest wind component is in the vertical. Well, not necessarily strongest, but we've got a lot of wind in thermal wind. It's not really a wind. We've got a lot of convection going on. And as you see, like even the jet level is getting diverted by how strong the updrafts are, by how strong the vertical rising motion in the convective areas are. Like even the strong rotating jet stream wants to go around this thing. That'll also cause the divergence aloft, also causes rising motion. It goes hand in hand. When there's a vacuum created up top, things rise to fill the vacuum. It's like a power vacuum. If you assassinate a dictator, it doesn't take long for someone to fill that power vacuum. You can't just assassinate a leader and think that things will change. You have to change the entire system. You can't just take high wind away from the top level and expect nothing to be there. You have to, when high winds divert from an area aloft, there's going to be a sucking up of things from below. So that is all sweeping up into the Rust Belt, into the Northeast. We're going from the Southwest into the Corn Belt, into the Rust Belt. A really good Midwestern plains system. And by good, I mean bad. Really strong, not good. Let's just, for shits and giggles, let's take a look at the day-night microwave. Oh, yeah. Look at that. Look at that. So we've got our lower, moister air coming in Texas and Louisiana. We've got our stronger upper level winds, both. We've got upper level winds sending this way, but also this way. And they are spinning up storms. Remember that directional differences in wind also create spinniness. And velocity changes in winds also create spinniness. Let's see. What else did I want to do? I wanted to look at something else and I forgot what it was. I think I want to look at, I haven't looked at the SPC website in a minute. Let's see. Got some really steep lapse rates behind this. Ton of warm air advection. Warm air advection is feeding this storm from this direction, and it also spins back in at the spinny point of this wave. You can even see the crashing wave shape up here. All the warm and moist air advection is going into the heart of this. This is forming a wishbone shape, honestly. Let's also take a look at our mid-level. Is it mid-level convection? Oh, no, that's boundary layer moisture mixing ratio convergence. This is a scalar divergence field generated by multiplying the mixing ratio by the convergence of the wind in the layer between 1000 millibars and 925. Okay, so that's lower level mixing ratio and wind convergence. And we've got some really strong values here in central Oklahoma, where we're seeing that really strong activity. Let's take a look at our Cape. Holy God, that's a lot of convective available potential energy. That is the tornado juice. And then also cinch is, CINH, is pronounced cinch for some reason. Convective inhibition or negative area is the capping. So that's what squeezes it down. That's the pot on the lid that helps the pot boil faster, but also keeps it from boiling out of the pot. Really high Cape and cinch means that you're going to have a lot of pressure building up really fast. Yeah, it's a that's a doozy. Let's take a look at our mid-level. What else do I want to look at? Frontal analysis. This is our big warm front right here. Warm front right here. Stationary front behind. Let's look at our... yeah. Do I want to look at anything else? Precipitation forecasts. Looking at 6 hours, 1 inch. Looking at really high dew points in the feeder zone here. And our temperatures, not cold enough to stop this. And here's our isobars. So we are looking at, I mean, let's take a look at our 300. Our upper level winds are showing some divergence right where our warm air advection, our warm moist air advection at lower levels is happening. So lots of spin, lots of fuel. Perfect day for tornadoes, honestly. If you're a chaser and you didn't get them today, maybe don't be a chaser. If you are a meteorologist and you're surprised by any of this, maybe don't be, I mean, maybe study more. Let's see. What else am I going to talk about today? We've got, I totally wanted to go to something else and I forgot what it was. Let's take a look at windy. No, I don't know if I like this one because it doesn't, I've got rain. This is gnarly amounts of rain. That's how much? Yeah, 1.85 inches per hour there, almost 2. Let's look at rain accumulation. That doesn't show it very well. Yeah, whoa, look at our thunderstorms. That is what it looks like. So imagine if you're on a wave, you can imagine it like surfing in the ocean. If you were looking at this storm as if it's a wave, this big stretch from Texas to Oklahoma is the inner curve right here. And that's where you feel the angular momentum of the crashing wave a lot more. So, of course, this is where there's a lot more suck. There's a lot more along the storm edge suck here. Now, it's still stormy back here. It's like being on the back part of a wave. Since you're on the outer track, you don't feel the angular momentum quite as much. There's not quite as much suck. And there's also 2 different directions of suck. This is like convergence and divergence. We've got convergence in the north to south and divergence in the east to west. That is confluence and difluence. That is, it creates a saddle. Like in math, it's called a saddle. I know that's weird, but math, there's a mathematical shape called the saddle, and that's what we're getting here. It's not optimizing energy to flow to one point very well. So it's kind of getting split between going to this low and going to the Canada low, which was yesterday's severe storm warned low. I don't like this map very much. Let's go to null Earth. And we can really see what the winds are doing as we move through the atmosphere. Let's do wind speed. And here's, we're looking at the surface as we go to 1,000 millibars or hectopascals. I'm sorry, this one is in hectopascals. This is up to 850 hectopascals, which is when we start getting into the mixing layer up to the cloud level. That's where we're looking at a lot of the convection happening. The 700 hectopascal level is where we're seeing some of this meet up with upper level motion. And the 500 level is when we really start to get fed into the trough and the jet stream. And up at 250, we're now looking at a slight cutoff low shape, but it's still pretty well embedded in the global jet stream, like this big thing. And then as we get into the 70 and 10 hectopascal levels, we're basically in the ionosphere at that point. This is the gradient between terrestrial weather and space weather. Speaking of that level, there's some really strong wind in South America and Antarctica at that level right now. We've got a polar circulation with a wave number of like 1, 2, 3. I don't know which. I always, it's a hard judgment call to do. I think it's a wave number of 4 or 5 there. But our North Pole rotation is a little less healthy. It's really loose and spread out. Speaking of spreading out, let's take a look at our... I did say that we've still got a active eruption in the Reykjanes Peninsula. Oh, this doesn't have SO2. This only has sulfate. Yeah, sulfate is SO4, right? It doesn't have... We're not really going to see much volcanic ash on this. Well, we'd see the ash. Let's look at areas that have... Yeah. We're looking at some plumes, but not looking at... not seeing the sulfur dioxide, which is what we want to see to look at volcanic eruptions. Let's go back to our air. Go back to air. Where's space? Oh, aurora. Yeah, we don't have very much aurora possibility today, even though we are at a KP index of 4 and we're in a slight geomagnetic storm. We're still looking at, we have biology. There's our fires. Got fires all across Mexico, just everywhere. Up here in Venezuela, we've got... Okay. Fires here in Iran. Fires in the Himalayas. Fires everywhere. Don't have any wildfires noted there, but let's go to air again. Oh, I can keep the layers on? Awesome. Sometimes it doesn't let me do that. Let's see. This is at a severe risk of fires right now anyways, too. So, let's take a look at this. Oh, man. And look at our dew points. Or not dew points, but our relative humidity. And that's different. That's a ratio. Relative humidity is a ratio of how moist air could be to how moist it actually is. So some of this is as moist as it possibly could be. And then we have this dry line, this line of dry air behind it. That provides contrast in order to sustain the vorticity, to sustain the convection. You need some difference in order to sustain the storm, because the storm doesn't... You can't just say it's wet here and so there is storm. You have to have the contrast, this really sharp gradient between moist and dry, hot and cold, low and high pressure, to be able to sustain the rotation and the formation of the storm for so long. Let's take a look at our precipitation accumulation. Really high. Let's see, what units am I in? I want to do... Oh, why won't it... Where's the setting for units? I swear there's a setting for units. I don't know. Well, let's go to a different projection because I like doing that. Here's our stereographic projection. And this way, you can pretend that you're inside the earth looking out. And you see all this fire. You see all this wind and rain. You see a really good snapshot of the way that the hemispheres work this way. I just prefer this projection because I think it's neat to think that I'm inside the earth. What do I want to show right now? Total cloud water, mean sea level pressure, misery index. That's a fun one. Let's go back to temperature. Let's go back to temperature. Zoom out. Take a look at what we're dealing with here. This is the polar vortex that is very loose, very falling apart, and driving these winds from the east to cycle back into... Actually, let's take a look at sea surface temperatures. Let's take a look at sea surface temperatures and show you what this, the air that's coming out of this low in Canada, what it's cycling over to be able to feed back into this storm system. Because, wow. Here's our high-ass sea temperatures, sea surface temperatures. Now, this is absolute sea surface temperatures, not the anomalies, but I want to show you winds over that. You see how it cycles in, up, down, and through? So this is really cold air. It's not picking up a whole lot of moisture here, but as it moves south and gets warmer, warmer air can hold more water. So as it warms up, as it moves down towards the equator, it can hold more water. There's also more energy available in the ocean surface itself to evaporate the water and get the water into the atmosphere from the ocean, because that's why water makes your water drying on your skin makes you cold, because it sucks the heat from your skin. It's a endothermic reaction. It takes energy in order to evaporate water. So you need the energy of the hot water to be a good source of evaporation. Also, the heating up of the air mass from just being in conductive contact with the surface of the ocean raises its moisture content capabilities. So all of this is one big machine for just a continued influx of hot, moist air meeting this super dry continental air mass behind it that's coming off of the Rockies. There's not a lot of moisture coming on shore here right now. There's a lot of air lifting up, going high in the atmosphere, and really drying out because, again, it's cold up there and it has to get rid of all that moisture. It condenses as dew, it falls as rain, it does a lot of different things, but really, as you lift the air parcel up the mountain, it gets drier. And then as it sinks back down east of the Rockies, that gives it a nice cold, dry air mass. And that cold, dry air mass, the dry line, acts like a stepladder for the moist, warm air that's coming in from the Gulf to get up into the atmosphere and convect and condense and become these terrible tornadoes. So speaking of tornadoes, I'm going to take another look at our radar. We're down to only 24 alerts and only one active tornado warning here in Cherokee, Wagoner, and Maize, Oklahoma. That is just southeast of Tulsa. Between Coweta, Muskogee, and Tahlequah. Let's see. Wagoner. Oh, that's another kink in the line type of tornado. warning. And this is observed. Okay, this was an observed tornado. Confirmed tornado was located 3 miles north of Tallahassee. Let's see. Source radar confirmed tornado. Who observed it though? It says observed, but then doesn't say that it was observed by a spotter or anybody. Let's take a look at our single site radar with this. Fortunately, we're very close to the Tulsa one. Oh, yeah, you can see that notch a lot better on the single site radar. Let's see it in motion. Oh, yeah, look at that wrapping. I mean, honestly, as it went over Tallahassee, it looked better. Looks like it's kind of getting rain wrapped here or trying to recycle back into the squall line itself. Let's take a look at the high-res velocity. Okay, there's the velocity couplet. All right, that damn sure is a velocity couplet. Sometimes these kinks in the radar can form their own little yin-yang of velocity anyway. Beautiful, beautiful, beautiful. Oh, sorry. Y'all aren't looking at the big screen right now. Let me fix my OBS to go back to atmosphere. All right. Man, we're at 2.5 hours, y'all. When do I get a Twitch raid? When do people come into my Twitch and follow me? I don't know. Let's see. And mute this before it. Okay. One viewer's on Twitch. I bet the other one is on oh no, that's just how many followers I have. Whatever. Yeah, we're looking at a nice little reaching down, scooping up the field mice and bopping them on the head kind of deal here in Wagoner, Oklahoma. Just southeast of Tulsa, Broken Arrow, and Coweta. It is now scooping up towards Locust Grove. We haven't even talked about locust or cicadas in a minute on this channel, but the cicadas are coming out this year. There should be a big one. Okay, there's another tornado warning now here in Eufaula, from Eufaula to Porham and Stigler. Let's take a look at that on reflectivity. All right. Looking like another kink in the line situation. Let's see. I'm going to take a look at our correlation coefficient on either of these. I don't know. That looks like something more on correlation coefficient. Maybe it's got a hail core. The Wagoner one doesn't look like it has much of a debris ball, but it could just not be picking much stuff up right now. Base velocity looking gnarly. Looking like it's got a little echo of its own. And remember that these spirals are fractals. The way that waves work is fractal. It mimics up and down, all the way up and all the way down. Spirit split. We split up and we split down. Let's look at our 1 hour precip. Fucking massive. That's a lot. Let's take a look at our... I want to look at high-res reflectivity and look at it in 3D. Here's one, a view that I haven't showed in a minute. 3D view of this line of storms. You see the wave You see the wave? Do you see the swirling? Do you see what I'm talking about when I'm talking about this storm looking like a little rotini pasta or a little spiral bound notebook where it's got waves that go up and down within itself? Let's show. Yeah, you can see it rising and sinking here. Now, this doesn't necessarily mean how tall the clouds are. This is kind of a histogram, or this is extruding the reflectivity towards a height in 3D, which doesn't necessarily mean the clouds are that tall. It's the intensity of the reflection of the radar signal off of the raindrops there. But you can still see usually bigger raindrops, meaning bigger reflectivity, show up in areas where the cloud is tall enough to have bigger convection. So while it's not necessarily an analog for cloud height, it is a way to think about how strong the storm is there. Let's see. We just got another special weather statement here. See what that says. Wind gusts up to 50 miles per hour. We got more here near Sonora. Oh, that's about to expire. We're looking at severe thunderstorm watch and a tornado watch all over the place here. And now this is just a radar anomaly. Remember that this patchiness could be from anything. That's just degrading the signal quality. It's just this last scan that doesn't look too good. But let's see. Let's take a look at this. Yeah, I mean, and today was predicted to be an extremely productive day for severe weather, and this did not disappoint. Yeah. This is okay, so both of these tornado warnings currently active are radar indicated. Let's see. I want to go to. Wow, you really see that wishbone shape taking place here. If the two legs of the wishbone sandwiched in together more, I'd be more concerned about Nebraska. But Nebraska is kind of just getting the resultant of both legs of this. Looks like Chicago is about to start getting their severe weather. We've moved closer to Bloomington and Eureka, Illinois. We're seeing a flash flood warning in northern Missouri. Let's see. Northwestern Carroll. All these counties. Let's see. Oh, this is a good little noodle. Good little noodle spiral here between Fredonia and Burlington. Look at those waves. Check out those waves. This Wagoner tornado is looking a little more wavy and a little less tornado-y. This one still hasn't shown me why they did it, though. What did I want to look up? Oh, I wanted to look at... Actually, I'm going to leave it on radar right quick and look something up. Okay. Looks like On the SPC website, we are looking at the most recent tornado warnings have been up in, or watches. I'm sorry. Is this a watch? Yeah. We're up to like 157. They've had a lot of watches today. They've been, okay, here's a mesoscale discussion that was just released. A new tornado watch or two will likely be needed in the next hour. Actually, I'm going to let you guys see this one because that's a good map of photographs. These are photographs. These are little, the squiggle shows what path something rising through the air would have. It's a map of wind direction changing with height. So the direction from the origin to the point is the wind vector. That means both the strength and direction of the wind is represented. Going from the cross to one of these little points shows you how fast, like the further away it goes, the faster it's going, and the direction is where it's obviously where it's going to. And as you see, as we get closer up to the little center of circulation, it starts to go haywire, but they look a little bit more uniform here. This is showing you the different geometry of the different levels of wind that's happening. And they are saying that a new tornado watch will probably happen in this stretch of area, probably into Northeast Arkansas. A mature QLCS, that is a quasi-linear convective system extending from northeast Oklahoma into central Texas, is gradually shifting east, though individual convective elements within the line are moving northeast. More discrete supercells ahead of the line earlier this evening have now merged with the QLCS, though some potential still exists for an isolated pre-QLCS supercell to develop from far north Texas into southeast Oklahoma. A strong southerly low-level jet is contributing to enlarged curved photographs. Okay, that's what I was showing you. And 0 to 1 kilometer SRH around 200 to 400 meters squared per second squared. This should continue to support rotation, mesovortex development, and tornado potential in the next several hours. Damaging winds to 70 miles per hour also will be possible in addition to tornado potential. And that was from meteorologists Laitman and Thompson. So this is what they're saying. The low-level jet here is contributing to the extended photographs. The blue shaded area here is where we're going from the initial wind level to the peak highest, fastest wind level. So most of it we're getting in the mid levels. This is basically where all the vorticity is coming from. And the greater the area between where we started and where we ended up in these first two levels this will show you it's kind of an analog for vorticity, kind of, a little bit. This is where we have the most juice for forming tornadoes. Not tornadoes necessarily, but like convection. And as you see on the other side of the front, there's zagging back. This is all zig and this is zag. All these curves reach an inflection point near the mid levels. This is showing a lot of available energy to create. Wait, I meant to come here to look at the storm reports because I wanted to see how many tornadoes we had today. Today's storm reports. Tornado reports, 27 reports of tornadoes. Wind reports 42, hail reports 86, 7 large hail, 2 high winds. Let's see. Like, for instance, metal roof torn off of residence. Land spout report. Multiple brief tornadoes just south of Moline, Kansas. Delayed report. Brief tornado touchdown. Video included via Facebook. Visual cone tornado reported buried in preset. So a rain wrap tornado. Power flashes. Large TDS impacting western Holdenville. That was one that was really big today. Hail reports. Let's see our sizes. Ooh, multiple Twitter photos. Let me see if this links. Oh, it doesn't link to where. Multiple Twitter photos showing golf ball sized hail, 250. I guess that's, what units is that in? Centimeters? Millimeters? Knox City, Texas. That's where we started out earlier. Golf ball size hail. We're looking at quarter size hail, golf ball size hail, a lot of very large hail. Yeah, that's some ginormous hail, a ton of tornadoes, as you see, spawning all the way from Texas to Wisconsin. So, well, really, we're looking at hail reports all the way to Wisconsin and Michigan, but tornadoes in Texas, Oklahoma, Kansas, and Missouri today, which is interesting because I think we were looking at, and large hail reports have been actually a little behind this area, so that as we swept through. Let's take a look at our active alerts again. We've now got 3 tornado warnings active, 2 in the Cherokee, Oklahoma area and 1 in the McIntosh, Oklahoma area. Yeah, this kink in the line that started near Okmulgee is now up at Locust Grove. It's the Wagner one, the one that's been going south to southeast of Oklahoma the whole time. This is currently tornado warned, both radar indicated, and here we've got another tornado warned storm west of Stigler or Eufaula and Warner. Let's see. I want to look back at velocity on these. I think I'm going to get a better look from this angle, honestly. Maybe not. Maybe not. It's very hard to see in this particular scan. Yeah, that looks like it's in a hole where there's probably a cloud in the way. This one's still showing pretty strongly. Let me see if it looks better from the Tulsa station. Oh yeah, that's a better look. Wow, look at that little yin-yang velocity couplet. It's scooping up through. Now let's look at this one. That's also doing the same thing where we're getting that good scooping motion. There's your couplet right there. This is looking like scooting through here. Yeah, it just picked it up right there. Let's see. I want to go back to reflectivity. Let's go back to my mosaic. Oh, I just saw a flash. We've got a new special weather statement here. Strong wind gusts. This is the area where they just had that mesoscale discussion issued for expecting isolated cells to spawn in front of the QLCS. You can honestly, you can kind of see some distinction between the edge and the backside of this QLCS as well. And yeah, here is where we are getting that swirling, that crash of the wave. This is the inside of the wave. This is the outside, the backside of the wave. But both very dangerous places to be right now. Heavy rain has moved into Orland Park and Chicago Heights. We are about to see this. We're about to see this QLCS span from San Angelo to Chicago. This is, oh man, let's measure this. Let's see. Okay, from here to here, it's like, that's like well over 1,000 miles long. Well over 1,000 miles long. About 7,000 miles long in one direction, and then, or 700 miles in one direction and 700 in the other. It's about 14,000 miles. That is a bonkers amount. And we see this keep spinning. This springy shape keeps spinning. Remember what a crashing wave looks like. This looks like a crashing wave to me, very much so, in the vertical plane. Whereas this is the side view slice crashing wave shape. This line that started in Woodward is not going away. It's moving into Cherokee. Even though there's a different place called Cherokee. There's many places called Cherokee in Oklahoma, I guess. Looking at really strong winds here. Again, this is where it's getting, this is the inflection point in the curve. This is where everything's getting funneled to. This is where we are looking at really big flooding risks. I have a feeling that we are going to move. Ada and Ardmore was where we saw our isolated cells spawning about an hour ago. So we are probably going to see our cells spawning here more near McAllister, Wilburton, Broken Bow. I know a lot of these areas are independent nations, actually, not part of the state of Oklahoma. So I hope everybody out there is doing okay and getting their weather updates. This one near Kiowa looked like it wanted to hook up, but has recycled itself. It's spinning it more in the parallel to Earth direction than the vertical direction. But you see the Chester Cheeto, the twisted Cheeto here, very much continuing to do its thing. This is the tornado that we are currently warned for. We got 29 active alerts currently. Yeah, that looks like it's getting big back here. That looks like it wants to produce a hook, honestly, these last few. I want to take a look at this on velocity. Near Enid. Enid is where they had a tornado earlier today. Well, maybe it's not hooking up. Maybe not quite. Not quite. Not quite hooking. I do feel like this looks like a center of circulation. Perhaps, and hopefully, I am wrong. Yeah, that's not that bad. It's not that bad. That's a scary looking storm, and for today, we're saying that's not that bad. Let's see. Oh my God, we're almost at 3-hour stream. Three-hour stream. Thank you to my viewers out there. My one viewer. Let's see. I think I need to wrap up soon because I'm hungry and thirsty and I kind of want to watch Avatar, but also people are in active danger. We still have active alerts, 30 alerts. We got 30 active alerts. Let's look at this Locust Grove one again. Oh, wait, I want to change back to radar. Sorry, y'all. I keep forgetting to switch. Let's look back at this one north of Tahlequah. Cycling itself back again. Just in this last frame, it's looked like it's had more of a velocity. I mean, look at that velocity couplet. Really strong definition there. Let's take a look at it moving through. Man, I just headed straight for Kansas, Oklahoma. Sounds like an oxymoron, right? Kansas, Oklahoma, but this is headed straight for Kansas, Oklahoma. Gnarly. It's beautiful. It's terrifying. It's awesome in the way that doesn't mean good, but makes you full of awe. This Warner one is looking like it's falling apart a little bit, but there's still a couplet. There's still a bit of a contrast there. Just now about to cross I-40. You see that? It looks a little bit bad, but really, I think this one that's crossing, what is this one? 412. We've got this about to cross 412. So if you are a trucker going through the Cherokee Nation, pull over. If you live in the Cherokee Nation in Oklahoma, get as close to the ground as possible. Get in your safe spots. Everybody, it's coming through. If you live in the Cherokee Nation and surrounded by the United States, Oklahoma, if you live in the sovereign nation of Cherokee out here, and the please, please, please take cover, take shelter. This is a continuing threat. Let's read what the National Weather Service has said with this. Moving northeast at 40 miles per hour. Debris. Take cover now. Take cover now. Take cover now. Let's see if this has a debris ball on it. Looks like this is what it would be. Correlation coefficient is lowered here, but I think this is the edge of precipitation. Am I right? Yeah, that's where we're not really getting precipitation. So that is probably high winds. And this is our rain-wrapped tornado. Rain-wrapped middle of the night tornado. It's also headed towards Jay, Oklahoma. So be on the lookout there. Let's see. One south of Warner and 40 is also looking like a serrated knife. Let's see. Let's take a look up in Chicago and see what the situation looks like up here too. All right, we are getting this line of storms that starts in Peoria is moving up towards Chicago. We're also getting heavy precipitation into South Bend, Indiana. So northern Illinois and Indiana, you are in for your dose of the severe weather now. Let's look at velocity. Probably won't show anything nasty on here. We're not in a tornado watch there. Not looking too bad there. As we make our way back, looking at a lot of serrated edge back through Missouri. The PDS was issued around here. Or the mesoscale discussion. I'm sorry, not the PDS. We don't have any active PDS warnings, but Arkansas might be in for their first. Okay, that we have a new severe thunderstorm warning here. Winds up to 70 miles per hour. That's a lot. They usually only go up to 60. Looking at Adair County, Delaware County, and Cherokee County. A line 4 miles southwest of Leech. Winds 70 mile per hour wind gusts. That's like near hurricane force winds. Expect considerable tree damage, mobile homes, roofs, and outbuildings damage. Yeah, so that is right here near I-40 coming out of Fort Smith on the way to Oklahoma City. We are getting a big, this QLCS is moving its current tornado-produced or radar-indicated tornado over I-40 right now. Let's see. Locust Grove tornado still going strong. The one that started in Muskogee, or really not even in Muskogee, has started in Okmulgee, up through Muskogee, and now is crossing 412. Just crossed 412. And is headed up towards J. I'm curious to see if they are going to extend this tornado warning, because it does look, it does still look pretty strong. Doesn't look like it's weakening to me. As we go from Wagoner towards its current, it looks like it's only organizing itself better. So I don't know, guys. I think that the warning is for 25 minutes long. I think that if this doesn't get weaker as it moves across 412, then it is going to spawn some more tornado warnings. We're looking at tornado watches still, all the way up into northwestern Arkansas. Yeah, look at that big old jewel. Yeah, you can see that inflow notch very well on this one. Doesn't look like much on reflectivity, but when you see that velocity couplet, oh, buddy. We can see out in front of the cell some spinning up of spinning up of cells out in front of the QLCS. Let's see if this has got a different view. This has definitely got a different reflectivity reading for the highest of it. Let's see what its velocity looks like. It's not really showing velocity very well, but the reflectivity looks a lot better. And by better, I mean worse. Wow. All you can say is wow sometimes. Let's see. You know what, y'all? This stream has officially reached 3 hours. This is twice as long as I've ever streamed before. I did work today, so I'm not like sleepy because I had a shorter shift than usual, but I am pretty beat. This has been quite the weather day, quite the weather stream. We've had a lot happening, and I think I just want to eat some food and go to bed. So, let's see. I love you all so very much. Thank you so much for being with me on the stream tonight. I go live every single night to review the weather all the way from volcanoes to solar weather and everything in between and beyond. Please follow me on Twitch and YouTube at Cloud Hudson or Today's Weather Tonight. This has been another episode of Today's Weather Tonight. Be safe. If nobody has told you today that they love you, I love you. Have a great evening. Stay safe, everybody. Good night.